we are with a tool, and that tool is our angular velocity, and we just saw that omega average is delta theta upon delta t, while omega instantaneous is d theta by dt. Okay. Okay, so now how do I relate my linear velocity with the angular velocity, right? Now again I draw that circle looking from the top, because it's easier for us to be working with a circle. Okay, so this is my circle, right? And this has a radius r, right? This has a radius r. Now just try to think. In a time delta t, it sweeps an angle say delta theta. Okay, so in let particle t sweep an angle delta theta in time delta t, in time delta t, and obviously I know, and let it be constant, let omega be a constant. Okay, let omega be a constant, so delta theta upon delta t then becomes equal to d theta by dt. Okay, let its angular velocity be a constant equal to omega, so that omega average equals omega instantaneous, right? It becomes equal to instantaneous velocity, and what happens? What is this length? This is, see, when your velocity is a constant, say even otherwise the translational velocity, you are moving at 5 meters per second, is it not? So after 10 seconds you will be moving 50 meters, and in 10 seconds you have moved 50, so 50 by 10, that's your average, which is 5. And even otherwise at all point of time you were moving at 5 meters per second. So instantaneous is equal to the average. That will always be the case when you are moving with a constant velocity. Okay, now understand? So now what happens? What is this length? This is r delta theta, trigonometry. No, it is r delta theta. That is the way we have defined radian, right? What have we said? If this radius, this arc length is r, if arc length is r, in a circle of radius r, if the arc length is r, then it subtends 1 radian at the center, right? So it comes from there. So it is that. Now what happens? Hope you understand this, or do I need to elaborate? Fine. So the linear distance moved by the particle is equal to r delta theta. So what is the velocity? Therefore velocity of the particle, linear velocity, right, of the particle is r delta theta upon delta t. After all, it has moved that distance, right? Maybe I should say the speed of the particle because I am taking distance, right?
Linear speed.
Linear speed. So the linear speed, yes. That is this. Now, what is delta theta upon delta t?
Omega.
This is omega. So if v is the velocity of the particle, v is actually equal to r into omega, magnitude wise. But v and omega both are a vector. Now you'll also understand, if v is a vector, then omega has to be a vector. Okay. And there's one more chaos. Now we'll just see. The r itself, r is a vector that is defined as having its tail at the axis of rotation and its head at the point to which we are referring to. Okay? So r is a vector with its tail at the axis of rotation, and its head at the point of interest. In this case, P. Now you understand? So my r is a vector. R is a vector. It is like that. Omega is another vector. Correct. R is a vector, omega is a vector, v is a vector. And r is multiplied by omega. Try to understand. Now, when is it so? There are only two types of multiplications that we know in between vectors. One is a dot product, another is a cross product. Now, if I dot it, it becomes a scalar. I do not want that. So it has to be a cross. Do we get that? Okay, so I write it, since omega, r and v all are vectors, so what happens? Does it has to be a cross product of vectors. Thus r and omega should be crossed, should be a cross product, cross product to yield v, right? Now I don't know one more thing. Which order? Which should be first and which should be later? Now you see, this has to be something like this. This is my v. Do we get that? Do you see this as a system of three mutually perpendicular vectors? This is the red pen, the red vector is omega. This, the black pen, is r. And this, the blue pen and the blue vector there, that is no. Angular velocity is red. Black is r. And this is linear velocity. Do you see it? See it as this? They are perpendicular, system of perpendicular vectors. Now, r and omega are to be so raised, so crossed, that it points in the direction of v. Now, this is omega. Should it be omega cross r or should it be r cross omega? It has to go in. It has to go in. I have kept the tails of the vectors together. I have slid omega down from there and brought it here. So if the red goes onto the black, that means omega goes onto the R, then it is a clockwise looking from your direction and it will move into the board.
Which is the direction.
So it has to be omega cross R. Is it not? It cannot be R cross omega. If it is R cross omega, fine, you'll get the direction, fine, you'll get the magnitude, but you'll not get the direction.
Get negative.
You'll get negative V. So it has to be omega cross R, and hence we decide that V is equal to omega cross R.
How do we take the magnitude of R? How do we take the vector R? How is it usually? I cap, J cap, P cap form? Is it a position?
Normally this is taken as a Z axis. This is taken as Z axis.
The axis of rotation.
Huh. Axis of rotation is taken as the Z axis. Okay? This I had drawn to make you understand the concept of the angular velocity. So maybe I'll remove this. Okay. That was when I had taken my origin to be at this point. Fine. Now let us go a step further. So this we understood. Now it could so happen that I fix my origin at one point. So let my origin be. This was when?
Origin is on the axis.
Yeah. Correct? Origin was on the center of the circle that I was considering. Now, if you take that as origin, then the moment you start talking about some other particle, obviously your R goes away from that, because R after all is what? R is a position vector. So its tail has to be at the origin. So fine, if you are talking about this and I have shifted my origin here, then what when I am talking about a particle rotating here? Fine, you understand that? So even in this case, let us see what happens if this is not the origin, because that's the trouble. It is still tentative now. You understand? It's still tentative. And you understand why it is tentative. Okay? Why? Because my R in the standard most sense, in the strictest sense that we understood, that R is a position vector. Okay? So R has to be like what? It has to be starting here and pointing here. Correct? And this is no longer my R. Earlier it used to be R, but now it is no longer my R. My R is this. Okay? So I have come here, this is my R. Hmm? This is R? So should I erase that? I'm erasing it. This is my R. You see? Now this R for that particle P is kind of this, right? It's going in a cone. Is it not? It's going in a cone like that. Now this is my R, and this is my omega. This is my omega. Right. Now what? Now what do we get? Wait, hold on. Fine. Now this R, which is like this, is made up of two vectors. A vector that you do the sum of the vectors. A vector that goes like this, okay, and plus a vector that goes like this. Do we get the point? Do we get that point? Now, now let me take this as origin, this as center C, so that I name them clearly. So my vector R is made up of OC and CP. Correct? Correct? Now, if I apply this, let us see whether it gives me the same result. So, if V is equal to omega cross R, then it becomes omega cross OC plus CP, which becomes omega cross OC plus omega cross CP, which becomes, now omega and OC are in the same direction. So what is their cross product? That goes down to 0. Why? The angle is
Sin theta is 0.
0, right? They are parallel. Cross product of two parallel vectors, mod A cross B is AB sin theta n cap. AB sin theta becomes 0. So it becomes a 0 vector plus omega cross CP, which is that radius vector. Right. So it simply does not matter where you position your origin. Correct? Where we position our origin becomes absolutely immaterial. So my V is still omega cross that vector that is perpendicular to the velocity, so maybe omega cross CP. So it remains the same. Correct? Wherever you take the origin. Do we get the point? Wherever you take the origin, it still remains the same. Many a times it is also written as V is equal to omega cross R perpendicular vector. This vector R, which is that component of R which is perpendicular to omega. Right? We understand that? So we have been able to not only define angular velocity, not only understand why we defined angular velocity. Okay, so we defined it, we knew why we defined it, we also were able to fix its direction, and not only that, we were able to relate it with the linear velocity, the velocity that we can actually sense, right? The velocity that we have been conversant with, the velocity that we are familiar with, right? So this is the whole concept, and we should know whys, otherwise things will crumble. You will not kind of get a hang of what is being talked about. Fine?